Hi, I'm Josie South. I'll be discussing the interacting effects of emerging contaminants on an invertebrate food web. I'm a postdoc at the South African Institute for Aquatic Biodiversity, where I work on trophic interactions and global change ecology. I was the recipient of European Union Horizon 2020 Aquacosm grant to take a team of interdisciplinary South African scientists to the Netherlands to complete work on interactions between emerging contaminants. This is the Emerge Interact team, and this is the team from the Netherlands Institute of Ecology. There's been somewhat of a media panic in the last few years regarding pollution in waterways, and yet there's still little definitive evidence of microplastic pervasive effects on freshwater systems, especially when considered at environmentally relevant conditions. Besides microplastics, waterways are also polluted with many pharmaceutical products. There is next to no information on the possible interactions between microplastics and pharmaceuticals in single species, let alone upon wider trophic interactions. This oversight is likely to lead to erroneous conclusions which result in poor legislation changes. There is also a likelihood of absorption of pharmaceuticals onto the microplastic surfaces. This stressor interaction may result in either synergisms or antagonistic effects on the focal species. Again, there's next to no information on any of these. We therefore designed a series of factorial experiments looking to address these gaps. We used a multi-trophic food web of Calborus flavicans, which is a biting midge larvae, and Daphnia magna. We investigated two common contaminants, which were microplastic beads and fluoxetine, which is also known as Prozac, a very common antidepressant, which is a selective serotonin reuptake inhibitor. The approach was twofold. We used automated behaviour analysis to determine the mechanistic explanation of a phenomenological analysis using functional responses. Functional responses are used to describe resource consumption with regards to resource density and can be used to characterise population-level impacts of predation. The functional response model predicts parameters of attack or encounter rate, handling, and maximum feeding estimates as a result of the handling estimation. These are quite abstract parameters, so by using the combination of methods, it allows us to ground truth the model estimates from direct measurements of movement, albeit in this case, the movement parameters were not measured in terms of anti-predator responses. We used a commonly found microplastic bead side and based the fluoxetine concentrations and microplastic concentrations on Dutch surface waters. Treatments were a control, fluoxetine only, microplastics only, and a microplastics and fluoxetine combined treatment. We were also interested in the effect of time on the effect of the contaminants. Therefore, the behaviour analysis was completed 20 minutes after exposure and 24 hours after exposure, and the functional response experiments were run for 2 hours after exposure and 24 hours after exposure. Linear mixed effects models were used for each variable of distance moved and velocity of speed in the behavioural analysis, which takes into account the repeated measures of time bin and animal ID as random effects. Here, the parameters of Calborus distance moved and velocity of speed are presented with relevance to the black line, which is the control mean. There was a very clear short-term hyperactivity effect of fluoxetine, while microplastics also induced a small increase in short-term movement parameters. In the long term, there was a decrease in movement compared to the control for both microplastic only and the fluoxetine and microplastics combined treatment. Contrastingly, for Calborus, the chronic fluoxetine only treatment returned to normal levels. Daphnia magna experienced similar short-term increases in movement parameters, where there were increases compared to the control, with the hyperactive effect elicited from the fluoxetine-only treatment. In contrast, the chronic experiment showed a massive increase in movement in the microplastic-only treatment, a reduction in the effect of the fluoxetine-only treatment, and a return to control values for the combined treatment. These graphs show the functional response curves for 2 hours and 24-hour experiments. The orange line indicates the maximum feeding estimate for the control experiments, and the shaded areas represent bootstrap 95% confidence intervals around the mean number of prey consumed. This allows the functional response to be considered at a population level. Where there is overlapping confidence intervals, it indicates no significant difference in functional response magnitude. A generalized linear model was applied to see whether the presence of fluoxetine or microplastics had an effect on the number of Daphnia consumed. Neither had a significant main effect nor interaction effect in either the 2-hour or the 24-hour experiment. Across all the treatments and the timeframes, there was no change in attack parameter, which indicates the encounter rate. On the other hand, in the 24-hour experiment, the handling time was significantly longer in the microplastics only treatment compared to the combined treatment, which resulted in a lower maximum feeding rate for the microplastic treatment. Although both were slightly higher than the control, there were no significant differences in the maximum feeding estimate between the fluoxetine only treatment, the combined treatment, and the control. Equally, there was no significant difference in the maximum feeding estimates between the control and the microplastics only treatment. When both species movement parameters are presented together, it is clear to see where the mismatch occurs, which is driving the lower feeding rate in the microplastics only treatment. The kernel density plots indicate the distribution of data recorded in 60-second time bins throughout the 20-minute recording time. The biggest difference between species movement is seen in the plastic-only treatment, which is increased by the disordinal interaction, where there is minimal change in Calbora's movement between time periods, whereas Daphnia increases its movement. If you compare this to the other treatments, you can see that the scale of change is more or less the same across time periods. This is made even clearer when you consider the velocity of speed, i.e. the escape and pursuit capacity. Here, the microplastics only treatment is the only one where the interquartile ranges don't overlap. Therefore, this suggests that the capacity of Calbora's larvae to even capture the Daphnia is very reduced. This is particularly poignant when you compare it to the control data distributions, which completely overlap in ranges. What we conclude from this is that contaminants have species-specific effects, which can interact differentially depending on the time period. There is clear evidence for absorption of fluoxetine onto the microplastics, and evidence that this can have an antagonistic effect to negate the effects of the fluoxetine. However, the effect and the magnitude of this effect is different depending on the species. In this case, the Daphnia can ingest the microplastics directly, whereas the Calbora's larvae do not. So this mode of action is likely to be driving the differences in the species. In terms of population level differences, despite the changes in behaviour, the actual effects of all of the treatments on predator-prey interactions are very subtle at environmentally relevant concentrations, and none of them deviate from the control. However, further cascading effects on higher level interactions ought to be considered in the future, as well as further incorporation of different time effects. This work was funded by European Union Horizon 2020 Aquacosm Transnational Access Grant and made possible by Nodus Technology loaning us a Danio vision for the duration. A considerable input was made by the Netherlands Institute for Ecology technical staff, and additional support was channeled from the SAIAB and NWU funding schemes. At the time of the research, I was funded by the DSI NRF South African Research Chair in Inland Fisheries and Freshwater Ecology. My name is Josie South. My contact details and Twitter handle are here. Please feel free to get in touch, and thank you for listening.